Welcome to Swine Time podcast here at Pipestone. I'm your host, Dr. Spencer Wayne. I'm one of the staff vets here. And I've got a couple of guests with me today to talk about PRRS, Dr. Karyn Havas and Dr. Scott D., two folks I have the pleasure of working with. And the topic is not just PRRS, but Lineage 1C 144 PRRS. So, big mysterious topic, a lot to cover, but without rambling more, I'm just going to stop and say, Karyn, why don't you tell us about yourself, and then Scott, you could do the same.
Sure. So my name is Karyn Havas. I'm a veterinary epidemiologist and also have some training in economics, and I come from working on transboundary animal diseases with the U.S. Department of Agriculture and then also with Cornell University, and joined Pipestone in December 2019.
Okay, you don't live here locally. You actually live out
do not.
right?
No, yeah, I live in Pennsylvania, so I get to come visit, which is great.
Yeah, and you have a very special skill set. So I should point out, I'm a guy that runs through barns and gets crap on my boots. Karyn is a thinker. She thinks about stuff. She's very bright and has a very specific set of skills, just like Liam Neeson. So she's very, very talented. And then Scott?
Scott D., Director of Applied Research. Been here 10 years now. Prior to that, faculty member at the University of Minnesota. Prior to that, swine practitioner, getting poop on my boots too for 12 years. So it's a good thing. Good place to start. And happy to be here again at this cool podcast. Thanks for inviting me.
Yeah, known Scott for a long time, and I practice where Scott used to practice. So sometimes I find coveralls in barns that say Scott on them.
They probably wouldn't fit me anymore.
But they fit me. So
yeah, there you go. Good.
So, anyway. So the topic, Lineage 1C PRRS, and really maybe just a commentary on PRRS in general. You guys want to kind of set it up, because with being at risk of saying an answer that I think I know the answer to, I should ask it, but it feels like a lot of PRRS this year. How bad actually is it in general, and how bad is this Lineage 1C as far as just what people would say and recognize is happening?
Well, it's certainly gotten a lot of press, but I don't know if it's that surprising. Because I'm a microbiologist, like Karyn's an epidemiologist. I'm a microbiologist. So I study viruses and bacteria and how they change and evolve over time. And if you go back in the history of PRRS and you start looking at the emergence of the very first isolate in the late 80s, we called that 252. Then about 94, 95 came 142, which was highly virulent, and it started killing all these sows. We'd never seen anything like it before. The world was falling to pieces. Well, about 6 to 8 years later after that came a virus called 184. And the interesting thing about 184 was it was extremely pathogenic. It was even worse than the previous strain. It was killing sows, high pre- and post-weaning mortality. Viral loads in pigs were astronomically high. And that's a virus we learned actually could travel by the air. That's when we proved out to almost over 5 miles we could catch it in the air. That was something different. And then about 6 to 8 years after that came 174. And up until now, 174 was our primary isolate. But at 174, I remember when it showed up, killed all the pigs on the sows. So nobody weaned a pig for weeks and weeks and weeks. Killed many post-wean pigs and lots of mortality in sows. I remember going into barns and it was totally silent in there because there were very few live animals.
Yeah.
And now here's 144 about 6 to 8 years later.
Yeah.
And so I call this the PRRS clock. So it's a long answer to your question, Spencer, but I don't know if this is necessarily worse than what we've experienced in the last, say, 2 iterations.
Yeah.
And we can talk about a project when you're ready that we're going to try to figure that out. But that's what I call a PRRS clock, because this virus changes as it evolves through pigs. And every once in a while, the right or wrong piece of the virus changes, and you've got a virus that's all of a sudden out of this world, as we say, in virulence or pathogenicity.
Yeah. No, you're right. That clock, did you say about 5 or 6 years?
Yeah, or 5, 6, 8 years. Yeah.
I had it be a little shorter, but we all have short memories. And so we all remember, like, oh, that was the worst thing in the world.
Yep.
And they killed all the pigs. But then to go along with that statement is, if you go back a couple years later in that same area, my sow farm broke with PRRS, it's 99% or 98%, very similar to that virus. It's still, you can tell it's a descendant of it, but it's not that bad. And you think, what happens? Because we measure this little 4 or 5 sequence, and it's terrible. And then later, you got a very similar looking virus on this little thing we do measure, but something else in that virus must have changed because it's way less harsh. It's just an easier virus.
Exactly. And viruses are smart. We have to remember that they have to live in a cell to survive. And if they start killing all of their hosts, they won't have any cells to live in anymore, and they'll wipe themselves out. So they self-attenuate, meaning they get less. They're still pathogenic. They still cause disease, but they're not as you say, as devastating as they first came out of the chute. So they're smart enough to figure that out. If they don't change their ways, so to speak, they might not be around.
Yeah. Yeah. Now, if you ask people today, being so fresh, they would say, well, the old ones didn't kill 40 to 50% of the pigs on lateral introductions and the nurseries and finishers. This feels exceptionally bad, but it always does. So you have to temper current concern with history.
And that's one of the things, just as a little FYI for everybody. In July through September, we're going to run a set of projects in our BSL2 facility looking at some of these questions. The virulence of this virus as compared to 174. Are they different? Are they the same? We're going to look at do vaccines work? Another thought is this new 144 vaccines don't do any good. We're going to test that. We're going to test it with the Elanco vaccine and the Boehringer vaccine. And then biosecurity fails. Well, we're going to test that too. We're going to test various protocols. We're going to look at different disinfectant efficacy. We're going to look at feed transmission, feed mitigation efficacy. We're going to collect aerosols. We're going to look at human contact and do the boots and coverall changes we practice, hand washing. Does that work? We're going to study all that stuff again. I'm going to bet you that in the end, I'm going to see no difference between the two viruses statistically. And the vaccines will provide partial protection like they always do. And the virus, bacteria, the biosecurity protocols will work.
Okay.
So just a little, I'll put my neck on the line there a little bit.
But what you just said, if I frame it up, is that we'll do all this stuff and look, these viruses really won't be that different. It's just this one is the new one.
That's my hypothesis. Now, I could be proven wrong, but I'm going in with that mindset. You're not going to see real big differences.
The one thing about this current phase we're in with this current virus is the CT values you can measure are so low. It looks like there's just massive amounts of virus. Which maybe that's part of the driver is that, well, it's getting around biosecurity because just there's so much of it.
Yes.
The virus itself maybe isn't particularly bad, but there's just so much of it.
I think you're exactly right. That's called fitness. So viruses are fit. If they're very fit, they can replicate at high rates. And the virus we're growing up for this challenge experiment I alluded to, it's already growing to 6 logs in cell culture, 10 to the 6 TCID50 in cells. And so that's a ton of virus in the laboratory. And so it's growing like crazy. And think of what it could do in a pig, which is its natural host.
This is the new virus you're talking
about?
The
144.
Okay.
Yep, the one that we're growing up challenge for this experiment that I alluded to earlier.
Okay.
But it's growing like weeds. So it's really interesting.
Okay.
But I think that's why. I think it replicates so well that the viral load is probably just like a atomic bomb went off.
Yeah. So we got those trials lined up for this year yet? Or?
July through September.
Okay, so that's fast.
We're going to put the hammer down and we're going to share that information with the industry. We're doing it as a service, not just for Pipestone, but for the actual industry.
That's the Scott D fast.
Yeah, we're gonna get her done. And Behring is sponsoring it with us.
Okay, so some help.
Yep.
Your expertise and your drive. We'll know some things in a few months.
We will.
Okay, excellent. We already covered that this is like an exceptionally bad year, at least it feels like it I would say for the amount of breaks we're having. This is exceptionally bad. We're having more farmers break than normal. If you look at charts, it appears to be the worst that I've seen since I've been on practice.
It's not good, that's for sure. And it's summertime, so it's another bit of a twist to it, too.
Yeah. And then one other thing was that it's not all this one, the Lineage 1C. It's about a third of that, but 2/3 is just other viruses.
Well, that's what Karyn's analysis has kind of showed us.
Did you break it down by genetics?
Yeah. Okay. Yeah, I broke it down by variant. So we've had 23 breaks in the last year, and 7 of them were 144. So the rest included some of the variants that Scott mentioned, and only 7 of the farms had the 144. So in doing the analysis, I couldn't just even restrict it to 144 because there wasn't enough of them. I did not look at mortality. I did not look at abortion rate differences yet. Hopefully we can do that next. But it's not the only PRRS out there, even though it's the only PRRS we're talking about right now. Mm-hmm. So.
Yeah, I know within our own set of farms, we'd have farms break back in the fall that we didn't expect to break. And they didn't wean pigs for weeks and weeks. And they weren't the 144 Lineage 1C. So you're exactly right. it's not just that. You looked at a bunch of stuff in your analysis, though, everything from roads to density to everything else.
Yeah, health levels.
Can you cover what you found in broad or fine strokes, whatever you want to?
I'll try to keep it fairly broad. So one great thing about the Pipestone system and the number of farms that are involved in it is we have a nice database from that, right? If we were just one farm or 5 farms or 10 farms, we couldn't really tease apart what works and doesn't work. But because we're so broad and so big, we can do some analyses, statistical analyses, to figure out what's working and what's not. So when you look at the different farms and which ones broke with PRRS and which ones didn't, what I found was the state you lived in mattered. So that's pig density. Herd size did not matter. Health level did not matter. If you filtered, really mattered. And it seems that feed mitigation has a strong correlation with disease status as well. So feed mitigation was a little harder to look at because all the farms that were negative, all of them used a feed mitigant. So when it's that aligned with an outcome, you can't actually analyze it. So I just have that one table saying, all right, everybody who used a feed mitigant, everybody who is negative used a feed mitigant. Everybody who is positive, some used feed mitigants and some didn't.
Okay. You stop there for a second just because you're using terms that we're used to talking about. Our listeners probably know, but filters would be the standard. Most people are familiar with that, and then be attic or any inlet filtration. All the air coming in the unit has gone through filters of different quality. And then the feed mitigant is, Scott, you've looked at all this stuff for a few years now. Everything from a formaldehyde sprayed on product to different types of medium chain fatty acids that are applied. But something that you've shown in your research goes in the feed. Virus doesn't live when it's in there. When it's not in there, the virus lives. Is that fair to say?
Very repeatable. It looks like, I think we tested 15 or so products, Spencer, and 14 of the 15 pigs performed better on a mitigant than when they weren't on a mitigant. And we challenged them with PRRS 174, PED, and Seneca virus. So we really hit them hard. And we had control groups, obviously non-mitigated diets. Those pigs blew up. And the pigs on the mitigated diets did real well, even if they were infected. Mm-hmm. We could still find evidence of, say, RNA, little bits of the virus in the bodies of the pigs, but their performance, their mortality was so much different than the controls.
Yeah, that's the amazing thing. It's like a soft break or something that's going on that the pigs do better despite the virus being there.
Yeah.
And that's repeatable too. That's happened several
highly
times.
Repeatable, yeah.
Okay, so 2 things that you can do that we found, filtration and mitigant, and then where your pig barns are located.
Yeah.
Highly influential, or I don't know how
So filtration was incredibly predictive of health. If you were filtered, you had a 95% lesser odds of having disease, of any PRRS. But 95%. I've done a lot of epidemiological analyses, and that's the smallest or largest reduction in odds I've ever seen in an analysis. So I was pretty stunned by that. So filtration was a very big deal. But with that said, it doesn't mean that all of the farms that broke, some of them were filtered. So this is layered on filtration, feed mitigation, location. Those are the big 3 we looked at, but that's layered on a really sound biosecurity system already, right? So if you don't have a good biosecurity plan and you're not implementing it well, layering those 3 on is not a cure-all. Mm-hmm. So it's really important to consider that those really reduce your risk, but you also have to pay attention to your general everyday biosecurity because you can undermine that easily by just bringing it in yourself. So
yeah, I think that's real important. Everybody's very frantic. I don't know, but people are really wound up about this new virus to the point of where people say, well, why even try? Mm-hmm. Okay, well, that can't be the right answer. Yeah. And then you look at the data and say, well, we're not stopping trying, but it's causing problems, but the feed thing helps. The filter thing helps. And the doing things right thing helps. And we're not saying throw in the towel, not even close, because there's a lot of farms that haven't broken yet. And so you hold the shield wall hard and keep going, but it's a lot of shields. Yeah. So I think I guess a word of encouragement to the listeners is, this isn't hopeless. No. Can't be. And there's a lot of farms that haven't broke. I shouldn't say that without knocking on somebody. But
that's true.
So good biosecurity, filters, and then the feed mitigant.
Feed and location. So it's hard to move a farm, I think.
Yeah.
It's apparently doable, is what I've learned recently. But, you could, if you're in a pig dense area, you're going to have more disease. The pressure's there. It's just like people living in cities versus in rural areas.
Yes.
Disease incidences are different. Same goes for farms. It's just a general principle across all species in disease. So, that's predictive as well.
Yeah, and just it's worth a small comment that, we work with farmers. We manage farmer assets. There's a sow unit here or there that we make create pigs for our producers. Wherever they're located, where the sow location is going to be really critical. And so when we build a farm for farmers, it's always in the safest spot we can.
Absolutely.
It counts for so much. Filters, feed, put it in a safe spot. So that goes right along with your observation that freeways and pig density, all those things probably screw you up more than you realize.
Yeah. There did seem to be, when you plot out all the farms, you can see they're all following major roads, and thus the outbreaks tend to follow major roads. So, we like to cluster for ease and purpose, but there's a loss there too. So, I'm excited to hear about your vaccine outcomes, because when you compared vaccinated farms to unvaccinated farms, it didn't make a difference. So I'm curious about that.
Yeah, this will be growing pigs. We won't have any sows involved, but we'll have 90 pigs in a group, and a bit of a 10% cedar challenge model with either 144 or 174. And we'll have vaccinates and we'll have controls, either the Prevacent vaccine or the BI Engelvac vaccine, and then the control group. And we'll just follow for 70 days performance. Yeah. We'll take lung lesions, take fever, rectal temperatures and things, and then look at mortality and gain too. So at least in the growing pig model, it'll give us a pretty good idea of some of these questions. Are the viruses different? Do the vaccines help at all? What are the quantities of viruses in the bodies of the pigs? We'll measure that. So I think we'll get a really nice overview of this virus. Maybe I'm all wet. Maybe it is way worse than 174. Yeah. But we got to do the study to really answer the question rather than speculate like everybody's doing now.
You're doing that at the Research Barn 6 with the high intensity, the filtered air coming in and out, and it's a BSL level.
BSL 2. Each room is its own individual space, so we can have different groups right next door, and we don't cross-contaminate because we follow protocol, and there's air filtered in and filtered out.
Okay.
And that's one of the things we're going to look at too. I don't think I mentioned it. We're actually going to collect air in the room. We're going to collect air outside of the barn after it's passed through the filter. So we'll be able to really look at what's the quantity in the room, what's the quantity out of the room, to Karyn's point on the effect of filtration.
Are the filters of the exhaust air the same quality as what we have in our sow barns that filter the incoming air?
Yes, they're exactly the same.
So if you measured it on the other side of the filter, you could flip it around and say, well, that must reflect somewhat what's able to get into the barn. This is on the outside of the barn.
Right. Yep. So we'll have collectors going inside and outside to look at that aspect too. We're going to try to make it as comprehensive as we can. I'm even going to swab myself, like I used to do back when I was in Minnesota, to see if I've got any virus on me. Then I'll shower, and go through the clothes change bit and see if I can find any more virus. All these basic protocols are getting questioned, and we have to validate them again.
Yeah. To be honest, I think that's one of the most exciting things about what we're doing is we can do the experimental work, come up with a method that seems like it's a really good intervention, put a lot of stock in it, a lot of evidence behind it, do it, and then evaluate it with our data from the field, and then go back and refine it. And there's not many people who are able to do that real experimental work and then field observation work and then experimental work. And I think that's just fantastic.
And now we've got someone like yourself who's got the skills to take all that data and analyze it statistically to see if those interventions actually are real or not. That's something we've never really had the ability to do until you joined our team.
Well, it's a nice coupling to help out producers and give them the best options. So
So to kind of summarize, PRRS has been, I would say, noticeably bad this year. We have one strain that people are very concerned about that we're studying with your research come up here in the next few weeks that will determine a lot of things about it. And meanwhile, we've done some good analysis of our current breaks and put it with the background of farm density and interventions that have been put in place and found that filtration definitely helps. Feed mitigate helps. And pig density doesn't help. Inverted. It's a negative correlation. And I'd say my own editorializing is, if things help, don't give up hope. For anybody out there that's really worried about this, just say get in touch with the person you know at Pipestone. Stay tuned with what you're finding, Scott. If we do your vet work, we would be your resource for that. And you're likely hearing about this virus, but if you have questions, give a call to the person at Pipestone that you know and find out more. That is it. Thank you for joining me today. I appreciate it.
Thank you.
Yeah, appreciate it.
Stay tuned to our listeners for the next episode of Swine Time podcast here at Pipestone. Thank you.